So I'll wait for like a couple minutes and then I'll start. Right, so I'm gonna start in like 60 seconds, I guess. Not sure how many people are gonna show up. One person left. Okay, I think I'm gonna start. So what I'm gonna do is I'm gonna talk for a bit about pointers. So I'll do a brief review of the basics, and then I'll do some of the advanced exercises. The pointer exercises are here, so just 190/pointers. What I'll do, I think, and there's not very many people here, so feel free to just unmute yourself and talk if you want to ask a question. I think it's better if it's interactive. So I'll do the first couple of questions just to make sure that we're all on the same page, and then I'll do some of the advanced ones. So, okay. So, like the first couple ones are like really nothing, so let me copy. So, like to define a variable, what you want to do is you just want to say something like, int a is equal to 42. So what does it mean? And, like it's good to spend a couple seconds just pointing it out. So it means that a is going to store the value 42. So that's what it means in math as well. If you remember, that's not exactly what it means in Python, but in C it does. So we just put 42 in A. So now they're asking us to, well, it's actually me that's asking. So I'm asking you to define a pointer to A. So what we have on the right-hand side is address of A, right? So A is stored somewhere in the memory table. The memory table looks something like this. Right, so here you have, so this is like C-style addresses, whatever, like address 1000, address 1004, and so on. And if we're saying address of A, in this case, this means 1000. So the value of A is stored in the memory table at address 1000. So that's this 1000 here. Just remove the OX so that it's not actually hexadecimal or anything. Something like this. So on the left-hand side, what you have is a variable whose name is PA and whose type is int star, right? So the star goes with the int, not with PA. So a variable of type int star stores an address. So for example, it can store the address 1000, or it could store the address 1008, and so on. Okay. So if you have the address, so PA is now 1000 as well. So if you have the address 1000, you can say, I want to go to the place where A is, which is here at address 1000, and change this value. And you can do it directly by just saying A equals 43, but you can also say, go to address 1000 and put 43 in there. So this star PA means go to whatever this address is. In this case, we happen to set it to be the address of A, and change the value there to 43. So if you look at the memory table, star PA on the left-hand side means go to the address, in this case 1000, and look at this value. And here we're saying make this value be 43. So here we are asked to store I'll get to this in a second. So here we're asked to change the value of PA to something else, but not change the value of A. So what this means is basically, you could change the value of A to 46, for example. I'll comment it out. We're not doing that like this. In the same way, you can say PA, I want it to be something else. Too much. For example, I want to say PA is now the address of B. So I'll go and update the memory table. So here I decided that PA is going to live at address 1008. And when I say PA is the address of A over here, that is when it happened that 1000 came to live in cell 1008. Okay, because I said, take 1000 and put it wherever PA lives, which we arbitrarily decided is 1008. So here we also have a B. So maybe B lives here. And when we're saying PA is address of B, that's the same kind of thing as this, right? So we're saying, take the address of B, 1012, and put it where PA lives. So replace the 1000 with 1012. All right, so the principle to understand here is that there are two different things in this case that you can do with PA. You can say, go to address PA and change the value to something else. Or you can say, I want the value of PA to be something new. So if I have a node that has my address, I can do two things, right? So I can go to my place and change what's in my place. Or if I just change the address on the node, well, that has no effect on my house, right? So it's the same principle here. You can say, PA used to be the address of A, and now I want it to be the address of B. That's fine. A doesn't care. Or I can say, go to the address PA and change the value there. Well, at the time, PA was the address of A. So if you go to the address of A and change the value there, well, the value of A would change as well. So, okay, so now let's do functions. So what's happening here? I'm saying I'll have a function that will take an address as the parameter. And then inside the function, it says, go to that address and change the value at that address. So this will have the effect of changing A to something else, right? The reason this can work is that you're doing essentially the same thing as what we've done here, right? So here we're saying set PA to be the address of A, and now we're saying go to the address of A, which is stored in PA, and change it to 43. Same thing here. We're saying set PA to the address of A. That's how function calling works, right? So you take the address of A and you put it in PA. And then you're saying go to address PA and set it to something new, right? Let me check the chat. There's nothing in the chat. If there's questions, I'm happy to take questions. All right. So what I want to do now is I want to basically go to the end of the pointer drills and do some of the more complicated exercises. So I wanted to kind of do a brief introduction to the first couple of them. And now I just want to do the more advanced ones. So again, if you have questions or like if you feel like you don't understand and you want me to do some of the ones in the middle, feel free to ask. So, okay. So I guess we'll start with 33. Okay. So here, if you remember, we got to go back to defining kind of struct student and stuff. So let me do that first. So something like this, right? So in struct student, don't mind the red. It's just because I'm mixing, I'm like not putting some stuff in functions, so it's not happy about it. So also I missed type def. So what I'm doing here is I'm creating a structure, right? So every student is going to have a name that's going to be 20 characters, and they're going to have an integer age. So here, what we're asked to do is to create a malloc allocated block of memory that can store 5 students. So how can we do that? Well, we'll say it's going to be a pointer to student. And it's going to be of size 5. So what we're doing here is we're saying to malloc, make me a block of memory that can store 5 structs that are of size 10. So that would be enough to store 5 students. So we now want to store it in memory. So that's going to be like this. So the reason this is of type student star is that the way blocks of memory or arrays work in C is you're saying if you have a block somewhere here, whatever, like 42. So something like this. So if you have a block of, this is small integers that are 4 bytes, I guess not small, the usual ones. What you need to do in order to know what's in this block, let's say that the block is like this. All you need to know is that there is 3 elements here, and they start at 1042. Right? How much does the block take up? Well, if each cell here takes 4, then if you have 3, then it takes up 12. So you go from 1042 to 1050 up to 1053. Does that make sense? Questions? All right. So that's gonna be like this. So now I want to make a function that takes a pointer to an address of a student and sets the pointer to point to a new address where is. Wait, what am I saying here? This is a typo. So this is the address of a block. So essentially what I want to do is I want a function that would create create a student block. So basically do this, but in a function. So I want to be able to say the block S is like this. And then I want to say create student. Something like this. So I want to change P block S to be a pointer to an address where a student can be stored. So I'll explain this in a second. So here's what's happening. I'm saying I basically want this kind of thing for a single student, and I want to do it inside the function. So I'm creating P block S the same way. And now because I want to do it inside the function, I need to be able to change P block S. So to be able to change P block S, I need to send the address of P block S to the function. So this is analogous to what's going on here, right? Where I need to change A. So I'm sending the address of A to the function. Here, P block S is already of type student star. So that means that the address of P block S is going to be of type student star star. That's just because a pointer to student star is student star star. So now, in the same way that here we had to say star PA, so I'll go to address PA and change the value here. We're saying star P block S. So it might be better to call it like pointer to pointer. That's, of course, just a name, but just so that this is distinct from this. So we're saying star P block, star P underscore block S is this again. So this is exactly like this. The whole point is to just change the value of this to a valid address. Okay, so Q35, well, we've already done this. So Q34 was the function, and this is the answer here. We did not do 27, so let's skip that. So here,
I have a question.
Yeah.
Should we malloc it to be 5 students or just 1 student?
Well, I mean, this question says a student.
Oh, okay.
But like, you know, like in principle, like it might be a more useful function if it took like the number of students as well. So like something like this. right? So that might be like block n. So that might be like a more useful function where you're also passing the number of students, and then you can create an arbitrarily sized block. So, okay. So we want a variable PPS that can store the address of P block S. So we kind of already had done this here, right? So here it was a parameter to a function, but that would be the same, right? Does that make sense? So it's the address of P block S. P block S is of type student star. So therefore, a variable that stores the address of a variable that's of type student star must be of type student star star. So, all right. And I guess what's supposed to be called this. So now let's say that we have this, and we want to change the name of the student at index 2. Okay. So let's go back and just think about integers for a second. So if you have an array like this, then what can you do? Well, you can just say int block at 2 is equal to 12 or whatever, right? So that's just the usual thing. You have a block of integers. You want the integer at index 2 to change to 12. You say just this. Now, let's say that you have a pointer to that. So I'm asking, where is the address of the first element of this block stored? And the answer is, well, it's stored at address int block, which is here. So now if I want to go back to just int block, I can say star p int block, right? So star p int block means go to the address p int block. What does go to address p int block means? Well, it's the same as going to int block. Essentially, the asterisk cancels out the address of. You can think of it that way. Is that making sense?
Yes.
So that's integers. So in the same way, I can say star PPS at 2. So that would be student number 2. I suppose this is one thing that you can do is like copy the characters one by one. That's, I suppose, a valid solution, but you're actually, so I'll leave it in, but you're actually allowed to use strcpy. So here it's a little bit tricky. This one is not legal. So bad Copilot. The reason this is not legal is that it wouldn't even compile. So you're not allowed to assign strings to, or like assign anything to arrays. You can change an individual element of the array, but you cannot change the whole array. That's just not a thing in C. It would not compile. So, sorry, where's... So here it's really important to maintain the distinction between arrays and just pointers to blocks of stuff, because those you could change. But .name in the definition that we have, I'm sorry that I'm scrolling. So in the definition that we have, it's an array. You cannot just say name equals something new. You can say name at 0 is equal to something new. So what you can do, however, is just do all of this with one line. So you can say strcpy and then name and say copy Jennifer into name. So here we need to, like, is it an arrow? Is it a dot? Stuff like that. So we need to think that through. So let me copy the definition of the block somewhere close to here. And then we have sorry, so this, and we have PPS being the address of P block S. Okay, so star PPS is of type student star, right? So star PPS is the same as P block S. So, okay. So what about star PPS at 2? So that's like this. So one way to think about it is just think back to integers. And that might be like, if it's intuitive, if the integers are intuitive to you, that's probably a good way, right? So here I'm saying, okay, so int block is of type int star. So int block is the address of the first element of the array. And then what's int block 2? Well, that's an integer. That's the kind of thing that you can put 12 in. Right? So that's kind of the usual thing. Block of integers, you go to at 2, that's just an integer, one of the elements of the block. So that's one way to think about it. The other way to think about it is to say, okay, so what is this really? Well, this is the same as this. That's a good way to start. And that's the same as star P block S plus 2. So P block S plus 2 is of type student star, right? So P block S plus 2 is just the address 2 cells after the address P block S. So it's still address of student. And then if you're saying star something, you're canceling out this. So therefore, star P block S plus 2 is just of type student without a star, because you're going to the address. Okay, my computer has frozen. You might or might not be hearing me. I will come back on the stream in 1 minute after I restart. Sorry about that. Okay, I am hopefully back on the stream. Let me restart VS Code. All right, so we're back. So we were saying P block S is of type student. Star P block S is of type student. So if you have something like student S, then s.name would be the appropriate way to access the field because S is not a pointer. So this is in contrast to if you have a pointer to student, then you would do PS arrow name. Okay. So for that reason, we're saying PS2 dot name. So that's of type not car star. So that's an array of cars, and therefore you can copy a string into this array of cars. So the kind of straightforward example would be you do car name, and then you can say like strcpy Jennifer into name. That's how you use strcpy. Okay. And that is how this was constructed. So we figured out how to refer to the name of the student at index 2. And then we copied Jennifer into that array. Is that making sense? Questions? All right. So
I have a question.
yeah.
So when we allocated memory for the block, did we allocate memory for like 5 blocks or the number of student blocks? Because I've been
Well,
confused.
in the question, we didn't really allocate it for the block. We just assumed that it's already there.
Okay, but when you say star P underscore P underscore S at 2,
So I'm assuming that it's already set up.
and it's a block and at that like position.
So the block is at position star P underscore S.
Okay.
So I'm just assuming it's already set up because it kind of says change the name. So it's presumably already there. So if we wanted to allocate it, presumably we would do something like create student block with something like this function, for example, or something like this statement.
Okay.
So, okay. So here we want to change the first letter, the first letter to J, and we want it to be a one-liner, and we don't want to be calling any functions. Okay. So what can you do? So here it's kind of similar to the strcpy thing here, right? So we access this array, and then here we just say copy Jennifer into this array. So instead of copying it into the array, we'll just say, okay, go to the name and go to element 0 and change it to J. Right. So what are the things you could do here? So there's not kind of like super interesting things you can do, but instead of star PPS, you can say this, right? So this is the same as this, and that's because Those are just all the same. And then, well, like this is just literally the same as this. You can just continue as before.
Hi, sorry, I have a question.
Mhm.
So, when do we know when to allocate memory? Is it when there are pointers, or like what situation do we know when to allocate memory?
Right. That's a good question. So, in general, you need to be thinking about like where are things stored, right? So I think the better way to say it is you do not need to allocate memory when the data is, you know where the data is, and it's not in a malloc allocated block. There are only two situations like that. So, or really one. So you could have just an integer, for example, or kind of whatever other type. And then here it's not malloc allocated. That's stored in the memory table. We don't really talk about the details. You could also have something like an array. So this is, again, not malloc allocated. So in any other situation, when you need to store data, then it needs to be malloc allocated. Now, what you asked is like when there are pointers, does it mean that you need to allocate something? And the answer is not necessarily. So here's an example. So if you say in star PA is whatever, so that's a pointer. However, this is the same kind of thing as this. It's just that PA is of type N star, right? So those are stored the same way. So, and there's no malloc involved here. And the reason is that not directly to do with the fact that there's pointers or not pointers. It's about where is PA stored, like literally PA. Well, that's the same as A. That's not malloc allocated because it's just a variable that was declared that's of type N star. So the better question to ask is, where is star PA stored? And the answer right now, it's where A is stored because PA is address of A.
Got it. And does it apply to other variable types, or sorry, data types?
Yeah, to any. So like that's the general thing. So let me just do kind of another example. So on the other hand, let's say that you have a block. So at this point, where is block or like star block? And right now, the answer is nowhere. So if you try to do block at 0 right now, that would not be valid. And that's not because block is like different from PA. They're both pointers to integer. It's because PA was set to be the address of an existing variable, but block was not set to anything. So block right now is just an address that's not an address of anything in particular. Okay? So in this kind of situation, if I want to now then I would use malloc, right? And now where is block stored? That's stored at the address that malloc returned, right? So that's kind of the answer to, well, like, if there's pointers, does it mean I need to use malloc? Well, no, like here, this has nothing to do with malloc. On the other hand, here it does. And the reason is that we decided that PA is just going to be the address of A. And A was not malloc, so it's fine, nothing to do with malloc. And then for block, we didn't say, oh, I want it to be the address of an already existing variable that doesn't need to be malloced.
Oh, so you only malloc when you're trying to access somewhere that doesn't have like sort of an existing memory address assigned to it, right?
I mean, you could put it that way, but really it's kind of malloc is like if in the middle of a program for this or that reason, I want a new space where I can store stuff. Right.
Okay, got it. Sorry, one more question. I'm still a bit like unclear about what block 0 is. I know that I guess like int start block is a pointer itself, right? But like what would int start block 0 mean? Like is pointer like an array or
Well, so I would say it's kind of the other way around. So an array is sometimes a pointer. So if you say something, so let's make this 5 or 4 or something. And let me copy the memory table. Find, yeah. So here's what this would look like. I'll make it really small. So here, if you say A is 42, like C might decide A corresponds to address 1000 and we'll store 42 at 1000. And then if you have an array, it's going to look like this, right? So maybe that's stored starting at address 10,004, and then you would have like 4 and 5 stored consecutively. So array gets converted to the first to the address of the first element when array is used. Right? So array at 0 means, let's do array at 1. So this in this case would be this. Right? So array at 1 says, okay, like array gets converted to 1004. And then array at 1 means go one step after 10,004 because it's 1 and get the value here. So star array, and that's the same as array at 0, means the value just at address 10,004, so that would be the 4. All right.
Okay.
So the connection is array, when used in an expression, gets converted to the address of the first element.
I see now. Thank you. And array 1 is like star ARR plus 1, right?
That's correct.
Okay, got it. Thank you so much.
All right. So I forgot what we were doing here. Right. So we were doing kind of variations on this kind of expression. So another thing that you could imagine doing is, can we convert this to an arrow? And the answer is yes. So you can do like star PPS plus 1 and then arrow name 0. And that's because this is not trivial. So that because yeah, Copilot was lying there. So that is because, okay, so star PPS. So first of all, to remind people, so A arrow B is the same as star A dot B. Those are just like literally the same. One gets converted to the other. So that means that star are unfortunate names to pronounce. So, okay, so this is, again, that is a lie, not true, is the same as PS plus 1. And then star PS plus 1 dot name is star PS1. Sorry, so this is arrow. So PS plus 1 arrow name is the same as star PS. That's not true. So PS plus 1 is what we want. And we want PS at 1 dot name. Right, so this is this. And then star PPS is the same as PS. So this is equivalent to this. And this is what we want. So this thing is exactly the same as this thing. Is that making sense? So that's just kind of like a little bit annoying, but it's basically algebra, right? So we need to come up with like another one, I suppose. What did they mean here? I think there was another one. So I suppose we did the arrow here. I suppose we could convert the arrow back to stars, right? So we can say something like, so instead of the arrow, we'll do dot. So to do the dot, you need to dereference here and do a name here, and we haven't done something like that yet, right? So something like this. Make sense?
I have a question.
Okay.
Why do you dereference P_P_S and then add 1 to it and then use the arrow? I'm a bit confused with that.
So to think about this is like star PPS is the same as P underscore S, right? P underscore
Yeah.
S. P underscore S is the address of the first element. P underscore S plus 1 is the address of the second element. So now we have the address of the second element, and we want second element dot name, but we have the address of the element.
So use the arrow.
Right.
Okay, and then what's PS again? Just a reminder, I'm a bit confused.
PS is just star PPS.
And it's a pointer to a block of names.
It's so yes, but to be more precise about it, the address of the first element of the block of students.
Ah, yes.
Okay, so
So
that
would
so that's
would
kind of
P
so it's like a situation that's analogous to this, except instead of integers we have students. But with integers, if you have so with integers, that's not the example. Maybe anyway, I'll sorry, that's not the integer example that I was using before. Okay, let me do a new example anyway. So if you have a block like this, you can have a pointer to that. Sorry. And then you can do like array block at 2, and that would be the second element. You can also do it like this, right? Because PR block is just the address of our block. So you do star PR block, that's the same as our block. So that's so another thing you could do is star PR block plus 2. And that's the same as our block at 2. And that's because this is our block. Star array plus 2 is the same as this. Is that making sense?
Yeah.
Yeah,
I have a question.
so it's the same, and like the way I came up with this is just like applying those rules. It's like obviously kind of this definitely does not fit in my brain, right? So I just did the derivation here on the right.
Okay, perfect. One last question. So let's say Jennifer is the first name stored in a block, would P
So
underscore S
note
plus
that we're storing students in the block. The students have names inside them. But yeah, go on.
yes. So P underscore S plus 1 arrow name wouldn't return J, right? It would return the name after that.
P underscore S plus 1 is student number at index 1. And then P underscore S plus 1 arrow name would be would be converted to the address of the name of the second student. So it wouldn't be J, it would be an address where J happens to be stored, and then one cell after that address would be E, and so on.
Oh, but it would point to Jennifer's block, right?
It would point to so name would be specifically the name Jennifer.
Okay.
Is that making sense?
Yes, it does.
Yeah. Okay. All right. So now we want a function that gets the pointer to the first element of a block of addresses of students. And we want to change the name of the student at index 2. So without the function, what does it mean? So if you go to PS2, you can go here and you can copy Jenny into the name. All right. Does that make sense to everyone? So PS is of type so PS2 is of type student, just like if PS were int star, PS2 would be just int. So that means that we just use dot because PS2 is just of type student. If the thing is of type student, not a pointer, you do dot name to get to the name. And now PS2 name is an array. So we can use strcpy to copy into ps2.name. Make sense? So now we just want a function for this. So that's just going to take student star ps and going to do the same thing as what I said. Right. Okay, so a pointer to a block of 10 pointers to students. So what we want is a block of pointers. So want a block of variables of type student star. So the address of the first element would be an address of student star. So that will be of type student star star, because it's an address of a variable of type student star. And we want 10 of those. So we allocate enough space to store 10 variables of type student star. And the type of the address of the first element has got to be student star star. So now we want to change the name of a student at index 2. So how would we do it? Okay, so we have a student. So we have a student star star, and that's the address of the first element. So the address of the second element is this. So if we have an address of a student at index 2, then we can say, okay, go to that address and get the name, so that this is a pointer to student. So that means that I can just say, name. And then here we want to change the name. So I guess I'll do like new name or something. And I'll copy new name into here. Make sense?
Yes.
Okay. Wait, I'm supposed to be calling, sorry. I think I was writing the solution to this. So here I'm supposed to call Q14. So we would just say change student name. And this would be change student name for the student at index 2. So the address of so this is the address of the student at index 2, and the address of the student is exactly what change student name takes. So this would be the call. So this would be like this. And it kind of builds off of that, right? So I'm sorry, I kind of was answering a different question, but here, essentially, we're doing this, and then we're doing arrow name here. And here we are doing kind of the same thing. So, okay. So actually, PS2, so here we're saying, so Q40, so that's the point. Oh, it's not exactly the same because here we take the pointer anyway. Okay. And here we want to call the function from Q43. So here it's kind of so here it's nothing fancy, we just call it. Right, so p block address s just goes here. Right. So kind of the general approach, like most of those things like are kind of finicky and not super easy. So I try to kind of demonstrate sometimes that you just kind of sit down and do the algebra like in the same way that you would do the algebra like in a calculus class. And sometimes you kind of can think just forward where the question is set up, and so, at least for the drills, the question is set up in such a way that like it says what you're supposed to do and you kind of know what the end result is supposed to be. So you just need to figure out the algebraic manipulation that you need to do, right? Sometimes you have to, like figure out the goal that you have as well, and then say, okay, like this is the variables that they have, and I need to get from the variables that they have to the end goal. And again, it's kind of like you just do the math. And I think the only way to kind of learn it is to just kind of try to do those things yourself. Because like it makes sense to me that like for most people, like they look at it and they look at me do it, and it's like a lot of stuff is going on, and it's like the same amount of stuff is going on as like in calculus, right? Where if you just apply the rules consistently and slowly, then you'll get there. But you want to practice a little bit. All right. So I think what I'll do now, that's about what I wanted to say about this. So I think what I'll do now is if anyone has kind of questions or requests that they're willing for them to be streamed on YouTube, then I invite you to ask now. I will then turn off the recording and talk to people without the recording as well if you don't want to be recorded. So any kind of questions that would apply to everyone that you want to ask right now?
Hi. So I know this question is kind of like fundamental, but I'm still a little bit unclear about so basically a pointer is like storing basically address to a value, right? And when you're dereferencing it, like what does it exactly mean that you're like dereferencing a pointer? Does that just mean like sorry?
So let's go back here. So here's an example, right? So PA is the address of A in this case. So that means that PA has the value at this point of 1000. So this is what's called dereferencing. So this is saying go to cell 1000 and change the value at that address. So this used to be 42, and then after you execute this, so this is saying so we already said PA is address of A, so that's why PA is this. And then we're saying star PA, so go to address 1000 and change the value at address 1000. So this used to be 42, and now it's 43. Does that make sense? Hello? Hello? Oh, there's something in the chat. Oh, okay. What is the type of star PA? So so that's the question in the chat. So the type of star PA is int, right? So
Sorry, I was muted. Sorry.
yeah.
Yeah, it kind of makes sense. So sorry again. What is the So I know PA is of type int star, right? Is that correct? And so when I'm saying start PA, like what is the type of that?
Int.
Oh, okay. See.
So star PA right now is the same as A. So and A is of type int. So you can think of this star as kind of canceling this one out.
Okay, got it. Thank you so much. So just cancel it. Got it.
Sorry, I did not get what you were saying.
No, I was just saying I get it.
Okay.
It's like a cancellation.
Yeah, that's great. Yeah. All right. Other questions?
I have a question about extract min for priority queue.
Okay.
I'm struggling to wrap my mind around the process of and like the goal exactly of performing extract min on a priority queue. Would you be able to like summarize it really quickly, or maybe go into the details?
Let me try. So let me just pull up the slides and give me 1 sec. So this is kind of an example of a heap, I guess. Well, this is a bad example. So here's an example. So here's an example of a heap, right? So over here. So the heap order property is that the parent is always smaller than the children or equal, right? So the point of having a heap is that it's easy to, it's fast to look things up in a heap, right? So specifically, you know that the minimum is always on top. And also, you know that it's an almost complete tree. So what we want to do is we want to maintain a collection of keys, and we want to maintain them in such a state that it's always easy to know what the minimum is. And also it's fast to insert and remove elements. Okay, so we could do it with just a list. The problem with just doing it as a list is that either insertion or extract min would be expensive. So either you have to spend all that time in order to insert into a sorted list, or you have to spend a lot of time when you're finding the minimum and removing it. Does that make sense?
Yes, it does.
So the goal here is to arrange the elements in such a way that it's both easy to look up the minimum and it's not too expensive to both remove and extract. And the way we do it is, well, like we have those kind of operations for insert and extract, which basically require either putting the thing at the very top or removing the, actually in both cases, putting the thing at the very top and then percolating it kind of either bottom to top or top to bottom, so that the structure becomes a heap again. And the point is that it takes all of log n operations to percolate up or percolate down. And that's because the height of the heap is log 2n. And you need as many operations as you have levels in the heap.
Yes, that makes sense. So my another question that this leads me to is, so would the data structure be some sort of list where you pop the lowest element and then you can insert elements at the end?
You're asking what that data structure would be?
Yeah, like would it be like a one-dimensional array where like you like I think we maybe discussed it.
Like it sounds here. Are you asking about the queue or something?
Yeah.
Okay. Well, so like as you saw, so we need to separate kind of the functionality from the implementation, right? So you could have, so I think you're describing a queue where you can like insert in the beginning and pop from the end, right? I think that's what you said, right? Yes. And you can think about it abstractly as just a queue where you want to be able to insert to the end of the queue and get the first element in line. So the element that was inserted before all the others, right? And you could implement it as an array, right? So you could say, well, I'm extracting from location 0 and I'm appending at the end. So that would work. Does that make sense?
Yes, it does.
But that's not the only thing that would work. So another thing you could do is a circular array, for example.
Oh, a circular
array. Right. So like you could imagine, so that's kind of what we had in the lab, right? So like you could imagine all sorts of possible implementations. Those are kind of logically separate from what the thing is supposed to do.
I see. How do you recommend we practice implementing this type of logic?
I mean, you could implement it.
And so, okay, sure. But like how, my question better phrase would be, how would we be required to implement this on an exam, perhaps?
Well, so an example would be, so like I wouldn't usually, although sometimes I would. I wouldn't usually ask like verbatim from the lab, right? But like one example would be, you can look at like the circular array question from the lab, right? And that would be like an example of a question that could be asked. And like you could imagine something very similar where the expectation is you actually had done the lab. Or you could imagine it being like, here is a new idea, go and implement it.
Okay.
So there's not, and I just kind of understand what you're asking is kind of like, like here's a thing where I could imagine the question being really difficult and I want to kind of practice ahead of time, right? That makes total sense. So the answer is, well, like there is kind of, in terms of practice, like there is the labs, there's previous exams. So look at those. Specifically with kind of variations on like exactly the kind of thing that you're asking about, where it's kind of like how do I practice kind of stuff that you could kind of implement with a list. Well, there's actually like not a lot of those questions. So like there's not a big specifically with lists. So there's not like an easy way to give like a lot of practice that's beyond what's in the labs and in lectures and in previous exams. But actually, like if you look at all of those, that's actually quite a lot.
Yes. Thank you for your help, Professor. That's it for
Sure.
me.
Yeah. All right. Any other questions? All right. So I am stopping the stream and the recording now. So if there's like personal questions, you could ask after.